Well, we're going to continue in our discussion of Chapter 11. We're going to be talking about electron configurations in this video. And what we want to be able to do is list the electron sublevels in order of increasing energy, and then also be able to write the electron configuration for elements up to atomic number 36. All right, so what do we mean by electron configurations? Well, they're just a list of the number of electrons in each energy level of an atom. Okay, and the principal energy level and the sublevel specify the energy level of an electron. And then we're going to kind of fill those energy levels with electrons when we write the electron configuration of certain elements, which we'll see in a second. So there's two principles that are used when writing electron configurations. The first is that at ground state, the electrons fill the lowest energy orbitals available. And then the second rule is that no orbital can have more than 2 electrons. And that's something we talked about in a previous video. Okay, so if these electrons are supposed to fill, the lowest energy orbitals available, how do we figure out the lowest energy orbitals available? Well, there's 2 ways, I guess 3 ways that you could do it. The first is you could just memorize it on the top. So this is a list of the sublevels in order of increasing energy, or you can use something called the diagonal rule. So with the diagonal rule, what you do is, well, you're going to draw diagonals on, well, first you're going to set things up like this, okay? You're going to list all of the S sublevels in a column, all the P sublevels in a column, D sublevels in a column, and F sublevels in a column. And then you're going to start drawing diagonal lines through these columns. So let me explain. So let's say I draw a diagonal line here. The first sublevel that I encounter is the 1s sublevel, and that's the first in my list here. Then the next sublevel I encounter is the 2s sublevel, which is shown here. And what this is saying is that the 2s sublevel has a higher energy than the 1s sublevel. Okay, the energy is increasing. Draw another diagonal, then I encounter the 2p sublevel and the 3s sublevel. Again, we're increasing the energy each time. Again, more diagonals, 3p, 4s, and so on. You keep drawing these diagonals, and it'll tell you the energy of these sublevels, okay? So, I'm going to go to another slide here. This shows it much better than how I was writing it. Again, you do all of the diagonals, and you can basically reproduce this order here. And that was one of our learning goals, is to be able to write these sublevels in order of increasing energy, okay? And here's it kind of depicted on the right. You have the guys with the lowest energy level down here at the bottom. The highest energy levels are on the top. And remember, for each one of these sublevels, depending on the type of sublevel it is, there's a corresponding number of orbitals. So for the 1s sublevel, there is 1 s orbital, and each one of these boxes represents an orbital, okay? Same idea. For the 2s sublevel, there's 1 s orbital. Now for the 2p sublevel, there's 3 p orbitals. Remember the px, py, pz. They kind of look like those dumbbells, if you remember from the other video. Then we go back to a 3s orbital, there's 1 of those, and so on. The d orbitals here, in the 3D sublevel, for example, there's 5 of them. Remember, they kind of look like clovers, except the one that kind of looks like a donut. So we're going to see this as we write electron configurations, but this is just kind of give you a visual picture of what's going on here. Okay, so this can come from the periodic table as well. So here's a list of everything. And when we can kind of split up the periodic table up into those sub-energy levels. We can split it up into sections. So for example here, the S block elements, okay, so any elements found in these first 2 columns here, and helium, who's all the way on the other side over here, they're S block elements, okay? So we'll see what that means when we do electron configurations, okay? We'll skip those guys in the middle for now. All of these guys are P block elements, so the 2p, 3p, 4p sub-energy levels are found over there. And these guys in the middle are the D block elements, okay? We're going to pretty much ignore the F block elements, but the D block elements are found in the middle. They're transition metals that we talked about in previous video. Okay, so let me just erase a few things here and explain a little bit more about what's going on here. And I might be jumping ahead a little bit, but when you go through the periodic table, these numbers here, right, in front of these sublevels, if you remember, those are the principal quantum numbers, okay? And if you remember, they correspond to the row number we're in basically. So this is 1, 2, 3, 4, 5, 6, 7. That's what these numbers are here, okay? So we're in row 2 and we're in the S block. This is the 2S sublevel, okay? If we're in row 2 and we're in the P block, this is the 2P sublevel. Okay, same idea here. If we're in row 3 and we're in the S block, this is the 3S sublevel. If we're in row 3 and we're in the P block, this is the 3P sublevel. I think I said this is 3P maybe. If I did, let me correct myself. I don't know why I'm feeling like I said it wrong. If we're in row 3 and we're in the S block, this is the 3S sublevel. I don't know if I said that, but that's what I meant to say. So maybe I'll rewind it and see if I said that correctly afterwards. So again, we're in row 3 and we're in the S block, that's the 3S sublevel. We're in row 3, we're in the P block over here, that's the 3P sublevel. Now, one thing to keep in mind, let's say we're in row 4. Let's take an example. So we're in row 4, we're in the S block, so that's the 4S sublevel. But look at what's going on over here. Well, hold on a minute. We're in the 3D sublevel here when we go across. And just something to keep in mind is that whatever row you're in, okay, whatever the number of the row is, when you get to the d orbitals, they're always one behind the row, if that makes sense. So if we're in the 4s, right, then it's going to be 3d. If it's 5s, then it's going to be 4d, okay, and so on. That's something we're going to do more of when we get to some examples, and it comes from the energy of these sublevels, if you would go back a slide. But I just want to say that here so that it's clear, okay? And as we do examples, you know why I'm writing what I'm writing. Okay, so let me erase some of this. I think it's going to become more clear when we start doing examples. We're going to do a very simple example first. We're going to do hydrogen, the first element. Okay, so here's how you write electron configurations. Okay, you locate the element on the periodic table. For hydrogen, that's easy. That's the first element on the periodic table. And then from its position on the table, identify and write the electron configuration of its highest occupied energy sublevel, okay? And then it says here, another note, leave room for writing lower energy sublevels to the left. For hydrogen, we're not going to see this, but for other examples, we are. Step 2 is to the left of what it's already written, list all the lower energy sublevels in order of increasing energy. And then for each filled lower energy sublevel, write as a superscript the number of electrons that fill that sublevel. So for example, if there's 2 s electrons, it's going to be written like this, where the n here represents the principal quantum number, okay? So it's going to be s2 if there's 2 electrons. If there's 6 p electrons, it's going to be p6. 10 d electrons, d10. And why these numbers? Remember, there can only be 2 electrons in each orbital, and for s orbitals, there's only 1, so that's 2 electrons max. For p orbitals, there can be 3 of them, and 2 electrons per each, so that's 6 electrons max. In d orbitals, there's 5 of them, 5 times 2, there could be 10 electrons max in the d orbitals. There's some exceptions here that we're going to talk about, okay? Chromium and copper. But for now, this is our rule, okay? And then confirm, finally, as a sanity check, that the total number of electrons is the same as the atomic number, okay? Because remember, for a neutral atom, the number of protons should equal the number of electrons, or the atomic number should equal the number of protons, yep, and the number of electrons, okay? So it's all the same. So here for hydrogen, it is in row 1, so its principal quantum number is just equal to the row, so that's a 1, okay? It is in the S block. If you go back a slide, hydrogen is right here. It's in the S block. So it'd be handy to have this in front of you when you're doing these electron configurations. Okay, so that's the sublevel it's in. And it has, I just go forward here, 1 electron, okay? Because again, for a neutral atom, the number of protons is equal to the number of electrons. So the atomic number is equal to the number of electrons. So that's for hydrogen. Here's for a few other elements that we're going to come in contact with this semester. But let's do a harder example. Let's write the electron configuration for aluminum. Okay, so aluminum is element number 13. So I'll just write its symbol here. Okay, so I'll let you find it on the periodic table for a moment. And I'm just going to go back to our steps. So here's our steps. Locate it on the periodic table. Check. From its position on the table, identify and write the electron configuration of its highest occupied sublevel. Okay, well, aluminum, if I go back to, so forgive me, okay, let me go back. Where is it located as far as what block it's in? Well, so it's right here. So aluminum is in the P block. Specifically, it's in row 3, so it is 3P. That's the highest energy sublevel that it's in. So I'm going to write that here. Okay? And then we're going to basically write everything leading up to it. So in other words, if we're in the 3P subblock, right, then I must also have 3S. All right? Because we're just kind of going backwards, and you can go to your list of increasing energies and just write everything that comes before 3P, okay? So also then 3P, we have 2P, okay? Again, just go back to that list of increasing energies. And then I also have 2S and 1S, okay? And that's what it says here. To the left of what is already written, list all the lower energy sublevels in order of increasing energy. And if you forgive me again, I keep switching back here, but I feel like I should show you this. This is the order of increasing energies. So I was here, right, in 3P for aluminum. So then I must have this one, 3S, 2P, 2S, 1S, okay? So now if I go back, again, bear with me. That's what I have here, listed out in order. All right. So that's the steps so far. So we're steps 1 and 2. Let me just erase some of this so it's less confusing. So now we're on step 3. For each filled lower energy sublevel, write as a superscript the number of electrons that fill that sublevel. Okay. So aluminum, here's one way you can do that. Aluminum has 13 electrons, right? It has 13 protons, it has 13 electrons. We get that from the periodic table. So let's just write out 13 electrons here. Okay, what do I mean by that? Well, this 1s sublevel or orbital can have 2 electrons, right? I'm going to write this out a little bit more spread out so it makes more sense. Okay, 2s, 2p, 3s, 3p. Okay, so this can have 2 electrons. So aluminum has 13 electrons. So you could do it like this if you want. Minus 2 is 11 electrons left. So then the next one you do from left to right. The next one, 2s, also has 2 electrons, maximum. So you've got 9 electrons left, right? The p orbitals have a maximum of 6 electrons, okay? Minus 6. All right, so this is, oh goodness gracious, that minus sign is wrong. So I got 3 left. How about that? We'll say that. I got 3 left right now. I'm running out of room. 3 electrons left, okay? So 13 electrons, let's say. 3 left. And then the 3s can have 2. Okay, so I have 1 electron left, and then that 1 electron goes right there. Okay, and again, just count. 2 plus 2 plus 6 plus 2 plus 1 is 13. So I have the correct electron configuration here for aluminum. Okay. So I hope that makes sense. It's going to make more sense when we do more examples and you do the homework, okay, and get some practice doing this. So let's make life easier though, okay? And I think let's do that in the next video. Let's stop here. I'm probably getting a little long. So let's just pause for a second. And in the next video, we're going to talk about this noble gas core configuration. Okay, so see you there.